and it's thinking about recording. We're online live from Dallas Personal Robotics Group around the globe, wherever you're dialing in, whenever. It's great. We'd like to share what we've been doing the last few weeks in our robotics-oriented kinds of things and throw questions out to the crowd. There's a lot of experience you can lean on, so anyone's welcome to join anytime. For tonight, it sounds like we're going to start off with Doug D, who's making progress on his line follower. So take it away, Doug D.
So behind me there, you can probably see the course. My wife has been painting it out for me. It's laid out on 6 pieces of styrofoam, and right now she has 3 of them done, and I haven't solved the first one yet, so I'm not rushing her. But it's surprisingly more difficult than you would think to read those PIDs and make your turns. But I've been through several different logic sequences of it, and I've got one I thought about as I was waiting for this that I'm anxious to try. And I'm also thinking about changing my layout of the PID controllers to see if I have better control of them. I should have brought my little car in here. I could have showed you what I was talking about. But basically, they're laid out 5 PID controllers on the front of my robot car. And I was thinking if I put the top 3 together, I would get a much quicker reading on if I was drifting off of center line. And I might try that instead of what I'm doing now, which is reading all 5 and then trying to behave based on what I'm seeing. Sometimes when it drifts offline, you're getting no reading, and then you don't really know where you're at, which is part of the course when you get to a blank spot and you have to cross it without deviating. But it's tricky when you're just driving down the line and suddenly the line goes away because you're not over with one of your PIDs yet. But it's all part of the fun, right?
Yep.
So that's all I've got.
You're really jumping into the deep end there, Doug.
Yeah.
I'm looking at your course behind you. You got some of the elements that are absolutely ball busters. So
yeah, I have solved the fork. I've solved the hard turn, and then I tweaked something and broke it.
Yeah, no, that's the way it is. Have you, Doug? I don't remember your background. Are you a software person?
Right. I'm a VB.net and ASP.net.
Okay.
Program.
So are you familiar with Git?
With which one?
Git.
Like the GitHub?
Yep. Well, GitHub is, yes, the name GitHub is from the program Git. It's a way to save versions of your program so that you can roll it back if you screw it up, or as you progress, you can save little increments.
Right.
It's a real cool. There's a lot of stuff on the web about it,
right.
And I believe that if you go to the DPRG video library, I believe, didn't Steve give a presentation on GitHub or Git? I'm pretty sure he did. So you might even look at that. And I'm just saying.
Yeah.
Everybody goes through this, and so you might find that a useful program to try to keep from losing the fox every once in a while.
I understand. Yeah. Now what I do, since I'm programming in Arduino for this robot, I just make a new folder and say I got version 2, version 3. I'm on version 5 right now, and 2 is actually my best version. I've tried some other things that
I don't mean to bust on you there, Doug D. That's the worst way to do what you're doing.
Yeah, I know.
Absolutely the worst way of doing what you're doing. Take the 5 minutes, learn the 4 or 5 commands you need with Git, and it will solve most of everything you just cared about.
Yeah, I know. I have never been a real fan of that source management stuff, but I should really just bite the bullet and do it.
You really should. I use it every day. I spit it every day. I do all kinds of things with it every day. And that saves me so much things. In fact, it gives you the ability to say, hey, I want to try something like you just did. Okay, cool. I'm checked in. I'm good. Let's go try some stuff. Man, that blows. Screw it. Reset. Bam. You're back to right where we were when it worked that fast.
I shouldn't do it.
No,
And what-
Also, I have a question. Are you finding yourself changing the logic most of the time, or just
None
tuning
of
some
that.
parameters?
Kind of both. But my biggest problem logic-wise is that with those 5 PID controllers out the way they are, I try to say, okay, there's a line coming up on the one side or the other side, but then it kind of loses it between things. And so my logic didn't quite work out. And okay, now let me do a little adjustment to get back. And I've tried different parameters to adjust my speed of forward and speed of turning.
The reason I'm asking, right? So if you're tweaking parameters and you're doing that in the code, one thing that I find invaluable is, and I wouldn't go back and do it any other way, is you got to have a way to change the parameters wirelessly, right? Remotely, without having to pick up the robot, change code, download something. And so if you can get to a point where you can just turn a knob on your laptop, and it tweaks a parameter, I would highly recommend you invest sort of the time to get such a setup in place, because I found at some point I just found myself spending way too much time tweaking parameters and every time picking up the robot. And so it's invaluable to have, because a lot of it is just tweaking parameters, right? You have your PID loops, you have all kinds of things that you need to tune all the time, and if you can do that wirelessly, it's a real game changer.
Yeah, I agree with you. I've actually thought about that, and I have my little wireless remote, and I thought, well, I could just push those buttons and make my changes, but I had to undo the remote because it was using the power wires that I needed for the PIDs, and I didn't have a connector that I could find a 5 volts somewhere else on that Arduino, so I need a splitter for that, and then I'll be back in track. But that is definitely a good suggestion.
Yeah. I mean, there are libraries out there that'll help you out. I mean, I don't think it can be done without any investment of time. So getting to that place is going to take a little bit of investment in time up front, but I think it pays off long term.
One thing you can do in an Arduino is, if you've got even a couple extra pins and you can set them up for analog input, you can have a potentiometer from ground up to VCC, and then pick the trimmer off that into the pin, and then just capture the voltage coming off that, and then as an analog voltage convert that. It's not actually that hard. This is like,
I know you think you're speaking English, but
the point is that, I mean, in fact, we could get offline and I can show you how to do it. There's lots of stuff online on how to read a voltage off of a potentiometer. Like if you search for a potentiometer, like, a trim control, and just you're getting an analog voltage off of that, and you measure it on one of your pins. In fact, one of my first projects that got me back into robotics was actually a Raspberry Pi, and I used 3 pins and 3 potentiometers for red, green, and blue. And I basically just exactly the same thing with an Arduino. You could do that. And I'm just measuring the RGB values of these and changing the color of a light. So I had an RGB LED, and I was able to change the color of that based on these 3 potentiometers. And you're effectively, with a PID controller, going to have potentially a P, an I, and a D. So you have 3 potentiometers, 3 pins, and then you could sit there and tweak the values with a potentiometer live, while it's running. And that's sort of what I think what Chris is getting at is, if you can actually do it while the robot's running without having to download something, you could literally tweak these knobs or with a screwdriver, get little tiny ones, and adjust the robot on the fly.
Right.
Yeah. Bluetooth is your friend. Bluetooth is where I would steer you towards, because every micro's got a serial port. You connect it to one of those little $5 Bluetooth modules, and then you have a counterpart module on the other end. You could use the Bluetooth that's built into your computer. I found that sometimes to be a little tricky, so I have just a pair of these Bluetooth dongles, and I don't know if I can dig it up here. And so you have a wireless serial link, right? So stuff that you ordinarily would do over serial connection, it just happens now over Bluetooth. Okay, there's a little bit of delay, usually not a big issue. And again, if you're not huge into sort of the softer side of things, you could keep it real simple. You open up a terminal program on your PC, you press a certain key, letter U, U, whatever, it makes it, does something, and letter I does something different, right? So you don't even have to worry about any kind of protocol if you wanted to keep it really, really simple. You just establish certain keys on the keyboard and maybe followed by a number, right? And that way you're changing some parameter. Again, without getting really, really fancy, you could, Bluetooth and, a few keystrokes on your keyboard, you can get a lot done actually.
Yeah.
Building off that idea.
Bending over and picking up my robot and going up and down the stairs to bring it to a course is about the only exercise that I'm getting now. So if I stop doing that, it's, I'm gonna have to buy bigger pants.
But building on that idea, though, there's plenty of apps that are for your phone that are made to work with Bluetooth, and they're basically different types of controllers. Otherwise, you can, depending on the particular app, you can build the screen. So, like if you wanted to build a screen with 3 potentiometers, you just kind of like specify them on your screen, and it just talks. So your phone's got Bluetooth in it already. So the only thing you need is the Bluetooth module on the computer, and that just needs a serial port. Now, I know you're not going to want to hear this, but you're going to eventually find that because of lack of serial ports that are available on Arduino, you're probably going to want to go to a Mega sooner or later. So you might, if you're going to get one, the cheap ones come from China, so you might take a look, at somebody like Banggood or eBay, and look up an Arduino Mega and see about, maybe, I think they'll be about $15. And
AliExpress.
Huh? For AliExpress, yeah. And maybe have one starting to come over by boat, so that by the time you finally feel that way. Huh?
What's the advantage of the Mega?
Well, it's got a lot more input-output pins, lots more. Okay. And the other thing it has is it has 4. It's got at least 3, but I want to say it has 4 serial ports. 4 serial ports. So that means that you can use the one that goes to USB. You can let it stay and not be shared. But when you do that with an Uno, every time you want to upgrade your program, you're going to have to like unplug the serial port from its second use and then plug it back in. Or you can use what they call a software serial port, and they work okay at low speeds. I'm not typically, can a Bluetooth do it? Can a Bluetooth do 115K, or is it? That's usually not a problem, isn't it? What's the max Bluetooth baud rate?
You got me.
Yeah, it depends on the module. I mean, on the wire, I think it's 700 something for some early version of Bluetooth that I recall sort of some of the details. But those modules that I'm using, and most of them that I've seen out there that just implement the Bluetooth serial port profile, right? So that they kind of pair up. They all do up to 115 to 100 without any issues. And again, on the air, the bit rate is much higher than that. So you got a reliable 115K connection.
Yeah, and I'm saying is you might, with software serial, putting a 115K baud might be a little bit of a strain for an Arduino as a second serial port. So, like I say, but it's no big deal with the Mega, and the Mega is the same thing as the chip is essentially got the same microprocessor on it. It's not any faster. It just has more outputs because it has more ports, and it has more serial ports and more other peripherals too, I believe. So I mean, you'll just find any, you might have to change a few pin numbers, but other than that, it's not like you're going to have to rewrite all your code from the beginning.
Right.
So I'm just saying this. It's something that you might want to research a little bit, and like I said, you can keep making progress with the way you're going, and then when the other one comes in, you can decide what you want to do. But because it will be bigger, it's about twice the size of an Arduino Uno.
The other alternative would be a Tiny, which is a lot faster than an Arduino and has more pins depending on which one you get. They're up to 4.1 or whatever now, and they're like 120 megahertz, and they've got more pins on the big one. They've got small ones and big ones.
Well,
I think it's a teensy, not a tiny, a teensy.
Sorry.
The problem with the teensy, it doesn't have as many general IOs as a Mega. And
really?
No, not coming out. I want to say they probably have about 28 pins total, and maybe 32, but that's it. But they do have more. I think every pin can be a serial port or something like that. Everyone can be an interrupt, so you don't have to worry about external interrupts running out if you're using them.
Here I just looked it up, and they've got 7 serial ports on the Teensy 4.1. It's got 32 DMA channels, 31 PMW pins, 4 digital
but
pins.
That doesn't mean they got pins that go to the outside world. How many pins along each side does it have? And that's how many.
It's got 64 pins on the board.
How many of those are little pads that are underneath the board, and how many of them are along the edge? I'm just saying is, you can use it, but the form factor is not as easy as a Mega. And if you're like I say, Doug, I know you're just starting out on this stuff. I would think there's nothing wrong with the Teensy. I got some. They're great, but they're more complex. Even though they're quote Arduino compatible, they're more complex than making the change from an Uno to a Mega. So
all good.
I'm just baby steps. I'm just saying. And will you end up with a Teensy? Yes, you will. But don't go there at first. That would be my advice.
Yeah, I'm going to stick with what I'm playing with for right now, just so that I get done with what I'm working on. But then you're right. When I'm ready to push it to the next level, maybe a little bit bigger board like a Mega is a good idea.
Yeah. Well, like I say, other than having physical space on your robot, which you probably don't because you didn't design for it, programming wise and everything, they're they're essentially the same. Obviously, one's got more functions than the other, so they got pins that do things that, like, I think they tried to put the Uno footprint on one end of the board. Okay, so one end of the board, all the pins that you have on your Uno are on the Mega. I think there's one. I think the I2C is different, and I think it has one more analog pin. So there's a few differences, but not very many. And then the rest of them are all additional functions and pins that you can use. And it also, like I say, one of the things that you find is if you're using external interrupts, which the first time most people use them is when they're going to be working with encoders. And when they're working with encoders, the best way to do it is to have 2 interrupts per pin, or as David knows, use one of the ARM chips, which has special encoders functions inside their timers. But if you're just doing it with an Arduino type code, you'll probably dedicate 4 external of your 4 external interrupts of the 5 that you have on a Mega, or the 2 that you have on a Uno kind of leaves you like 2 short. So that means you can't use the best configuration for a an encoder. You can use, what that means is if you're using the encoder on the motor shaft, not the output shaft, but the motor shaft, you'll see that you get an awful lot of interrupts. Otherwise, like my little robot that I showed last week, I want to say every time big wheel turns, it turns at 380 or 4,000 interrupts per side. So if you're feeding 8,000 interrupts per revolution and you're going 10 revolution, you can figure out it gets to be a load on a Uno pretty quick. But anyway, I'm just saying is something to think about.
Definitely, especially encoders, which I need to move up to. Right now, my robot doesn't have them, but I'm going to work them on my big robot when I finally get to it.
Yeah, I would encourage you to kind of make this an unofficial rule for yourself, even though you'll break it. And I'm not saying you shouldn't, because there'll be bargains that you can't bypass. But I'm saying that you should make the unofficial rule is you don't buy a robot motor unless it has an encoder on it. I mean,
that's probably what I will do in the future. I just bought these kits for now, but
no. I'm literally in the next stream. I got 4 or 5 kits because I was going to teach a course that are exactly like the one you've got. Well, 99% like the one.
Right.
You got.
There's several different models that look the same.
Yeah.
So it's start. And when I do the real robot, I have to have encoders because I need better control of where the robot is.
Well, yeah and no. Yeah, because what about if you'll get but you'll find that encoders have issues in that sense. But what they do, you will want to control your speed and your heading very carefully.
Right.
And that will be, I don't know what that is.
He's playing.
He's having a drug.
Sorry, guys.
Okay. So, but I'm just saying that.
That's okay. We're just talking.
It's definitely the next when your next big robot, like I said, you want to make sure you have encoders on it.
Right.
And you want to make sure that if they're not encoders at the wheel, they're encoders on the motor shaft.
Right.
Okay,
So I'll be probably asking y'all for recommendations on the actual motors later. I don't want to interrupt what we're doing today, but I'll need to get the right motors with the right encoders later for my bigger.
Boy, that's a can of worms, but yeah.
That's why I thought we'd put that discussion off. Dave's not here.
Yeah.
Well,
make sure the motor's not underpowered. That would be my main recommendation.
Right.
Because if you got motors that have the right amount of torque and speed that you need, then you have to worry less about closing a feedback loop using the encoders, right? You can get pretty good results just with, I guess the technical term would be feed-forward control. You kind of know, you give it this PWM parameter, it's pretty much going to go at that speed. And if you have a way of getting constant battery voltage, right? I think somebody has mentioned that last time. Then you don't even have to worry about your motor running slow when the battery drains. So if the motor is powerful, again, it saves you a lot of headaches in having to close a control loop.
I will certainly go with a necessary motor.
On that, I'd agree and disagree. I'd agree that you want a motor that's not underpowered. That's definitely true because there's nothing more disgusting than an underpowered motor. But I would say that you're going to need the encoder to go in an absolute. When I mean absolute straight line, you're going to have an encoder.
Yeah, my car doesn't.
Oh yeah, definitely encoder. I wasn't trying to say you don't need an encoder. Just saying it makes your life easier in controlling the speed.
Yeah, Yeah, if it's underpowered, it's a pain in the butt. And those little yellow motors you got, they're pretty weak.
Yeah, I know. I put one of those sticks down to see if it could climb over it, and it had a little trouble until I bumped up the power on the motor.
Yeah, yeah.
You know, that was just the way to. I'm really got that kit so I could practice the Arduino and some of the logic. And
That's the one we use in our training class. I mean, it's definitely a good start. You can't beat the parts you got for the price you paid.
Exactly what I thought. I've got a whole bunch of different sensors I can practice with.
Yeah. Cool.
On to Ray or Murray, whoever wanted to do their demo
Go
first.
ahead, Maury, if you're ready.
Go ahead, Ray.
Okay. I'm going to see if I can get this to work. Okay. Oops. Tried it a second ago and it got strange.
Did some fun things.
Okay.
While Ray's getting set up, I was going to mention, I think I did before once, Doug, that that Pololu makes these little tiny motors. They're called micro metal gear motors, and they're very popular in small robots. And you can get them in all sorts of different amounts of power and torque and gear ratios. And for a smaller robot, they're pretty ideal. And they do come with 3 kinds of encoders. There's 2 kinds of there's an optical encoder and actually 3 kinds of Hall effect ones with different connectors and stuff. And they're very they're quite powerful actually for their size, as long as your robot's not too big, or you're willing to gear down and take a higher gear ratio. But I've been really happy with them, and I don't use them on my bigger robot, but on my smaller robots, I've been using them quite happily. And they come in like 60 different kinds of them.
Cool.
I would second that. Pololu, big selection of the tiny motors, and they have bigger ones too. They don't just have the tiny ones.
Yeah.
So
yeah.
they have them in all sizes, encoders, no encoders, gear ratio, you name it. I mean, they have a lot of different motors.
And their email tech support is really excellent. Those guys are really helpful. If you contact them, they'll spend lots of time helping you out.
Yeah, Paulo is a wonderful set of motors and wheels and stuff.
Can you guys see my screen?
Yeah, and you
Yeah.
look you're like the devil. Like what's that character with the horns?
Oh yeah, yeah. Little horns
That's
there.
the special camera given the double image, it looks like.
Yeah, this is the depth map out of the Kinect. I think I can make it bigger if my mouse is twitching around here.
Oh, and you are on your Pi, aren't you? Cool.
Well, I'm VNCing into the Pi.
Yeah.
So this is the, it's translated into colors. Like the 2 blue things are doorways, and they're probably the furthest away. And as you get, it goes from blue to green to yellow to red,
Wow.
and then to almost like a white, and then you get too close and it kind of flakes out. But that's the depth map.
That's cool.
Yeah, so from this, it's pretty easy on a grayscale image or the color image to look for, those colors on the screen. Say the blue if you want to look for the furthest thing away, or if you're avoiding obstacles, maybe you want to look for red because you're, that's the closest thing, or that's what's in front of you. Let me see if I can move my mouse over because this is jumping around quite a bit.
And this is using that special camera?
It's using the Xbox 360 Kinect.
Oh, that's right. Yeah.
And yeah, so that's much better. And if okay, so there are other ones. And it's a little strange. They don't always come up right away, and VNCing in it makes it slower. It's just kind of the nature of things. So sometimes it'll work and sometimes it won't, but I think it's kind of on the edge of what the Pi can do if you have a VNC connection into it and you're hooking this camera up and, you know, trying to run OpenCV. And
you said you're using a Pi 3?
No, a Pi 4.
Okay, that's a 4 already. Yeah.
Yeah.
I'm still getting bogged down. Yeah.
It's OpenCV 4 on a Pi 4. But it's, yeah, like in this case, it's opening the window, but it's not filling it in. And you can see here it's expected 1,748 data bytes, but only got 948. So it's yeah, man.
Hey, Ray, have you run top just to see where all your resources are going?
No.
You just type top on the command line. It'll give you an output.
Okay.
And you can
come up.
Google. It's a Unix, Linux thing that's been around for years. And you can just type top and you get that. And then you can hit keys on the keyboard and it'll configure it live while you're looking at it.
Wow.
And you can see how much memory you're using, where your network's going, all that kind of stuff.
Yeah. Unfortunately, this one doesn't look like it's going to work. There is another one. That'll show both images. But I don't know if it's going to work with VNC either. I'm going to try to get out of this one. I don't think it's coming up. Come on, don't go demo mode on me. Yeah, it's still losing a lot of data bytes. Okay, I'm going to try to get out of this one. And, okay, I'm there. See if it'll open this one up. Okay, this is a Grayscale Bitmap. It's, you know, it's easier to work with. You don't have 3 bytes per pixel. You only have 1, just the grayscale. But here is if I can do this, there's one of the doorways there. And there's the other edge of the doorway back over here. They're white now. And as I get closer to the camera, it's black or dark. Until I get too close. Then can't resolve it. But most likely, I wouldn't be using the color. Well, I don't know. It depends. This is just faster to work with because you have to handle 2 less bytes for each pixel. And it's it's just shades of gray. Let's see if we can get anything else to work.
Be right back.
Let's see if this one will work. This should show both images at the same time. If it's going to work, but with the VNC, everything is slow, so it may not. Come on. Pretty please. Yeah, so I think I'm kind of at the limit of what the Pi can do. the VNC connection and everything else, it's not going to cooperate. But at least, if you're working with smaller images and with, grayscale versus color, it seems like it can handle that. And there were several different test programs, but I don't think they're gonna show today.
Do you ever hook your Pi up to a monitor?
Yeah, it's hooked up to one now.
Oh, but you're VNCing to it. I was thinking if you had it on the monitor, then you could maybe turn your webcam to it, and you could get the VNC off of it.
Oh, that's true. Yeah, I could try that. I don't know if the video quality is going to be any good though, because it's
yeah. I mean, we're all just trying things, right?
Yeah. Yep. Anyway, well, it looks like that's all it's going to work. The other thing I could try, just kind of go offline and is to do the meetup on the Pi and see if that improves it. It may, I don't know.
Right.
So we could try that. That's what I wanted to ask. Has anybody ever used the Raspberry Pi during these meetings to, as your main computer?
We're counting on you doing that and reporting back to us.
Oh, you are. Oh, darn. Okay.
Ray, I don't think I'm using a Raspberry. I've got a 4, but I use a Raspberry Pi 3 for most things. And if I was just using a regular browser with, just to do what we're doing, I don't think that if it wasn't doing anything else, I don't think it'd be a problem. I mean, they seem to be able to handle a normal single video page, like coming off of YouTube or something like that.
Yeah.
And that's all this effectively is a single video coming, video stream coming from a web page.
Yeah, it's frozen at this point. It's not responding to anything. Okay. Well, I think I'm gonna just get out of the VNC session and see what happens there.
Your speed improved.
Anyway, so couldn't show it all. Maybe like I said, I'll try it here, just directly on the Pi and see what it does.
Pretty interesting about that depth perception.
Say that again.
It was very interesting about that depth perception.
Yeah. To me, that's the most useful. I mean, you could.
So how you planning to use that output of that camera? I mean, what's your plan for what does it feed into? What algorithm or logic?
Basically, I was just going to use OpenCV and do blob detection for either the color or a range of shade of gray or range of color, small range. And if you can get the blob detection, you get the the centroid X and Y out of that blob, and you can use that for navigation. You can say, okay, I want to look at all the things that are all the paths that are openings that are the furthest away.
Yeah.
And you can use the typically you just use the X value to steer the platform towards that.
Yeah, I mean, I don't want to. Again, we talked enough last time about RAWs, and I hate RAWs for its complexity, but at the same time, there's certain things it's really good at, right? And one thing it can do is it can take the output of one of these cameras,
right,
and turn it into a LiDAR scan, or you can use the full point cloud thing, or you can turn it slice of it into a LiDAR scan. And then you got all kinds of other things you can do with that. But the LiDAR scan data, I find it just more intuitive to work with, right? Than a depth image, because the LiDAR scan gives you, well, it's like having 100, infrared range sensors on your platform, right? It just gives you all this range information, and then and then you do with it whatever you want to do with it. I just thought I'd point that out.
Oh yeah. I don't know if you saw that. You probably didn't. There's if you have a camera that's sensitive to infrared, either by removing the IR filter or using an IR passband filter, you can just use a line laser and look at that with a normal camera and get, depth readings out of it. And it's much faster than, mechanical rotating LiDAR. But this was, the sensors are cheap. I paid, $15 for one of them and $10 for the rest of them.
So what? $15 for that camera? You said no.
Oh yeah, for the old Xbox 360s. Yeah, you can get them on eBay. I went to the Goodwill and found 4 of them.
Wow.
But so yeah, instead of paying, I don't know, $180 for an Intel RealSense camera, this is like, 20 or $25. It's very cheap. And you have basically 2 cameras, the depth camera and the regular camera. So you can use it for, kind of both things in parallel if you wanted to, look.
Right. But it's not small, right? I sort of remember what that looked like. It's
yeah, it's a little, like a wedge-shaped thing, maybe a little more than a foot across at the.
How much does it weigh?
I had a guess, maybe less than a pound, or yeah.
Oh, okay. So it's not for a small robot, all right? But
well,
yeah.
Actually, on a small robot, I actually had mounted a microserver. I don't know if you can kind of see that in there, but in the very bottom of the front of the robot is a microserver and a Breakout Garden VL53L1X, which is their little LiDAR, not spinning LiDAR, just a single time of flight sensor. And when I get to do my demo, I can demo that, because basically I just run that back and forth, and I've got I get a millimeter value at a degree value, like 180 degrees. And that's, if you put it in performance mode, I can get the entire scan in about 3 seconds, which is pretty good.
Yeah.
And that's and that weighs nothing. I had that on a tiny robot this big, and it weighs a few ounces at the most. And it's cheap, the little VLX, what's it called? The VL53L1X. They're like $20 or something like that.
Oh yeah. Yep.
Yeah. So
yeah, there's anyway, I thought maybe, Harold looks like he's going down the Ross path. So, he may have been interested in that.
yeah, I mean, at $15, I mean, that's a steal for a sensor like that.
Oh yeah. And I think the Xbox Ones, their form factor is a little bit different. I think they have a little bit better performance. But still, for $20, you can't beat it. I think if you want that level of sensor. But yeah, any of the mechanical things are going to be extremely slow in comparison to a camera, that you're getting 30 frames, out per second. That setup that I showed you last week, that it's a global shutter camera, and with the line laser, you can get 240 frames per second of it. It is very fast. So if you're talking about when you get down to mechanical scan times, it's so slow that your platform moves forward, and if you don't incorporate the movement that you've done in between reads, then you're going to get distorted, patterns and stuff like that, because in time scanned at different places as the thing has moved forward. So, but yeah, it's like I said, for cheap sensor. I thought they were pretty interesting, so I was hoping to get interest in the club. Harold, are you interested?
I'm interested, but I'm not ready to work on that section yet.
Oh, okay.
But I have plans to do something like that in my big robot.
Yeah. Like if you wanted it to wander around.
Yes.
It is.
I'm going to have to admit I was a bit distracted between the cat and some other stuff. So I heard $20 thing. Am I interested? And it has something to do with cameras.
And Ross.
Ross. Well, I'm going to say yes on that probably. Especially because I was hearing some very high praise come out of the rest of the group for how much you got for $20.
Yeah, yeah. Yeah, I was on the Doug bandwagon. How cheap can I get? You know, $20 is it. So
Yeah.
but, yeah, and like I said, the first one I bought was $15, and then I bought a power supply for 10, and then found I think 4 of them at the Goodwill. So I think I have 5 of them now. So if anybody wants one, the cost is $10, but you have to get your own power supply. So and there's a let's see, what is it? Anyway, there's a www.openconnect.org. There's a wiki, and there's a pretty big community that supports it, and both sensors, the 360 and the one, which is the later one. But yeah, I thought for what it was a pretty neat sensor. And now I tried this probably 2 years ago in a Raspberry Pi 3, and the just standalone, no VNC, not even a Wi-Fi connection. It just couldn't do it. It would like start to open up the window, and sometimes you'd see like a few frames, and then it would just disappear. But now with the Raspberry Pi 4, it can definitely handle it. So.
So how much power is that Kinect's taking? You're going to have that plugged in while you're using it?
Yeah. It's a little strange. This one, this one has actually a external 12-volt 1-amp power supply. So I guess I haven't measured it, but I guess you have to assume 12 watts. That it takes to run the camera, and 12 volts that was a very common voltage for like security cameras to work at.
Mm-hmm.
So I don't know if they just follow that from that, but the Xbox One, it just has a USB connector, and it derives power from whatever USB port you plug it into. This thing, the power is external, and there's guys that have eliminated the external power supply and wired it into batteries and a boost converter to make sure it stays at 12 volts. So
there's so many versions of Xbox. So say again, what version of the camera this is?
Okay, the one that I have, all of them are Xbox 360 Kinects.
Xbox 360. Okay.
Yeah.
Yeah.
Okay, so there's a later one out. It's called the Xbox One. I don't know why they changed their nomenclature.
Well, because they come out. Well, the Xbox 360 camera was specifically for the Xbox 360, and the Xbox One was specifically for the Xbox One. There's also There's also a Kinect for Windows, which has some different characteristics and doesn't have quite all the hardware on it. You might want to get one of those, but Microsoft is phasing these out. So maybe you can get them pretty cheap, like Ray was saying.
Yeah.
They have infrared. I mean, especially the ones Ray's talking about there. They've got both infrared and optical spitting out the same thing, so you get lots of data back.
Yeah.
Yeah, I just checked on eBay. Yeah, I see one for $8. Starts at $8 plus 8 in shipping. Another one $20 free shipping. So they're somewhere all over the place there. So yeah, definitely looks like they are in abundance there.
Yeah, like Ray was saying, that the biggest issue with those on the Xbox 360 ones is getting a power supply for it. But people have hacked around that, and there you go.
Yeah.
You used to have a very specific connector to plug into the Xbox 360 on that thing, if I remember correctly.
Yeah, it looks like it is USB, but it's not.
It's not. Yeah.
Yeah. Looks very close to a USB. I don't know what you call it, receptacle, or I don't know what you call those. I guess the A connector socket. But anyway, that's the progress I've made.
All right, I guess I'll try to do a demo now. Hopefully my machine won't crash when I said the word demo, but let's see now. I'll try to, so So 510 now. Okay, now the robot is sitting there facing me right now. And I'm just going to go ahead and share my screen so you can see if I can get it to actually there. Okay. A window. No, a screen. I want to share the screen. And it's this screen. Yes. Sorry. Here we go. So hopefully now we'll get okay. So now on the top, we're looking at a fixed image. It's the actual camera image coming off of the robot. And the bottom is let's see, that's the console, the SSH session. Now, I was going to demonstrate that LiDAR first because this is the LiDAR test. So basically it runs that little servo and you get a depth measurement or a distance measurement at each degree. And it's pretty fast. I don't expect to be running that while the robot's moving. So for my purposes, it worked fine and it was relatively cheap and easy and lightweight. So now I'll go ahead and start the gamepad because this is a gamepad demo. And then I'll turn on the camera and I should be able to, let's see. Okay, hold on, here we go. Gamepad demo or test. There we go. Now, I'm running the gamepad entirely now. I won't have to type anything. So now I'm going to turn on the camera and go ahead and refresh this. So that's now a live camera. And I'll pick up the robot and put it on the floor. Okay, now we'll open the door. Now I'm going to step away from the computer for a bit so I won't be able to talk with my microphone. I'm going to drive the robot into my lounge and back just as a demo. Can everybody hear me?
Yes.
Okay, here we go. Well, here's my cat sleeping as normal. Now, what we're looking at is basically a video output, streaming video off of the robot, of course. And I've got a little LTR 559 sensor on the roof of the robot that does a light sensing. So you'll see that as I go in and out of darkness, it'll change the parameter on the camera itself. So that's the low light setting and the highlight setting. And it's basically if I shade the sensor or not. And that way I can get into a darker room and see my way around a bit better. So here we go.
Are those Koa wood floors?
Okay, enough of that. I think we'll call that a demo. How'd that go?
I think you're trying to sell your house. How much you want?
Yep. Okay. Stop presenting. Okay.
Is that Koa wood on the floor?
What's that?
Is that Koa on the floor?
Koa?
Yeah, isn't that one of the woods from Native Woods?
Oh, well, Koa is actually from Hawaii. We've got kauri. Oh, my wood floor is actually kauri, I think.
Kauri, okay, yeah. Huh.
Yeah, I never thought about it. Yeah. The red and yellow wood is, I think, kauri. Yeah, so anyway, that's been my project. Basically, I've got it running now. So there's a toggle switch on the robot that switches on and off a daemon that's running in the background. So I've got basically a Linux daemon running, And when I flip the toggle switch, it turns on the robot operating system. In this case, it's the Gamepad Demo. And then I can then take the Gamepad controller and use it. And at this point, like I said, it's just telerobotics. There's no autonomy. But I can switch the daemon over to run the robot operating system, and then it goes into autonomous mode, and then I don't have any control. Well, actually, that's not true. I can still tell the robot what to do with the gamepad, but if I don't do anything, it'll just run autonomously. And I'm still working out having it react to things, so that when it runs into a wall or something like that, it reacts appropriately, both on the infrared sensors and for the bumpers. The problem I'm having, though, is which is just came up in the last few days, is I finally got all this running with the video and everything. But if I turn on all those infrared sensors on the front, I think my Arduino, which is feeding that data, is feeding it too fast, and I'm using a message queue, and I think it's overflowing the message queue with data, and then the motor control doesn't work very well for some reason. And so the robot starts acting drunk, basically. It starts kind of going all over the place, and the control basically goes from what you saw to a very, very erratic control. And I think it's the message bus is getting overflowed with infrared data. But I think I've got the Arduino turned up. I can't remember what the speed is, but it's sending a lot more data than probably is necessary and overflowing the bus. But that's a technical detail I can probably work out. But point is, I guess I'm getting to the point where I'm almost ready to turn on that autonomous mode and just let it go. And that's, I don't know, 3 or 4 months of effort. But it's getting there. Thank you, Doug. And that's about it for me. I think, yeah, there's not much else to report that's new, apart from having the camera on the front of the robot. The only one thing that I realized is that I don't have any audio. And if you're doing telerobotics, I mean, on Mars, there is no audio. Well, there is audio, but it's not anything of consequence, so they don't really bother with it. But it would be nice to actually have audio coming in. And so I could add a microphone, but then syncing the audio to the video is something that FFmpeg can do, but that gets into a whole nother level of complexity. And at this point, as David Anderson would point out, I need to focus on getting the robot moving. And it's now moving, and it's actually running on PID controllers off the encoders, so that what you just saw was running on PIDs, left and right PID controller. And I still haven't got that working very well. There's still some tuning to be done, but so far so good. Anyway, that's it from me.
So one thing that I wanted to interject, you're probably using the Pi camera or some small camera.
Yeah, I'm using the Pi camera, the tiny one, 5 megapixel.
I haven't done it yet, but I've been getting ready to do something with just a web camera, because a web camera has audio and video.
Ah, yeah.
You picture syncing problems, and you can pick these up cheap. You just have to plug it into the other port. They don't go into the Pi web camera port.
Well, my biggest issue is space, and so like I managed to mount my camera right in the very center top, and I don't know if you can see that, but there's not much room for anything else in the front. I've got all those sensors now, and there was just barely enough room for a camera. I got a 30-centimeter camera cable, and you know, the Pi on my robot's in the very back of the robot, so I'm running the camera cable to the front. But there was only just enough room, literally to the millimeter, for that camera to fit in there.
Wow.
I wouldn't have much room for anything bigger, because I've actually got what are they called? Those little cameras on the gimbal mounts, the AI camera, and there's just no room on the robot for that anymore. I mean, I'd have to redesign the whole robot, and it's just not worth it. So maybe a different robot. Yeah, but yeah, it's a good idea. If I had a web camera, then I get audio right, you know, streamed into the same device, and then it's synced and everything. So yeah.
Right. Who wants to be next?
I mean, I'll go right fast. I don't have a whole lot to say, and then I'm not feeling all that well. So I will tell you, I got my my little yeah. I guess I can show you. Oh, I can't show you because I got the camera deactivated. No, I don't have it deactivated. Yeah, I don't. I was just looking. One of the things I was looking at was fix thing. Yeah, got it pointed all the wrong way. But I can do this. Woo. Okay. I'm going handheld. So I got my wheels going. I got a little Arduino thing happening there to test out my motor controller, and it's working exactly like I expected it to work. I managed to put a fan on the back of my Latte Panda, which revealed to me that the reason I was having so many performance problems is that it was thermal regulating itself because it was pretty hot, and I hadn't touched the back where the actual chip is, and it's running much smoother now. I reprinted a top case for the thing, so it goes right on the front. Looks like a little panda on it because it's a Latte Panda, and that's and I got things mounted up. And I got some bolts in to mount that thing up. I was going to do a couple more things, and then the Z mount on this thing over here decided to become no longer a Z mount, Z limit switch. So that's what I got fixed last night on the thing. I'm playing on it, but I went to go print some more stuff for it. And that's about all I got going on. I haven't really done any raw specific stuff in a little bit, simply because I've been able to do some hardware. Been plinking around the office. I say the office, the lab, the garage, making that a little bit better and that sort of thing. And yeah, I had a really fun time playing with that motor controller and bringing up the Arduino stuff to make sure I understood what left and right meant, and controlled it with PWM and forward and backwards, and like a servo controller. I'm able to get it pretty much from a slow turn to full speed, and full speed on these things. It says it's 190 RPM on it. I can't count that fast, but maybe it is. So, but the encoders are working well. The PID, auto-tune PID on this thing, when you finally, if you get it hooked up wrong and you say, auto-tune the PID, click the button, go. It'll go off in the weeds. Okay, cool. But as soon as I get it hooked up correctly, I said auto-tune PID, count to 10, and you've got it tuned for the motor. Do it on the second time. It just it rotates it one way for a little bit, the other way for a little bit, then jitters it back and forth for a little bit, and then you're done. And gives you your numbers. You write all that to the EEPROM on the board, and it's just working like crazy. So
but what is it tuning, right? So once the tuning is done, what do you get? You get perfect speed control.
You get accurate speed control and angular control on it. Yeah. Currently, I've got it in RC mode, so I just got it in differential drive mode. So one of the servo inputs controls forward and backwards, and the other controls left and right, anywhere from a slow turn to a outright spin. And it knows how to do the combination of if I'm going fast forward and I turn hard right, it knows how to slow down the wheels to make that happen. As much as how much of a turn that's going to be yet, I haven't got it on the ground to figure out yet. But it almost stops that right-hand wheel, and the other one's still going full blast. So it's pretty cool. That's about I've been that, and I've been trying to get my Twitch numbers up, and been trying to work on my studio, so to speak. So I made a mess out of it again already. But what else is new, right?
Right.
and but I am learning some stuff. I 3D printed me some tool holders, and that made life a lot better. But still, I currently got a mess going on. I got to unmess it. But that's just about it for me. I mean, I can talk a little bit more if you want, but
Harold,
how it goes.
Harold, what auto tuning software are you using?
I'm using something called the from Basic Micro. Here,
Can you put the link in the chat?
Yeah, and well, this is something specifically for their.
That's
They're-
okay. It'd be interesting to see how, like you said, it went first one way and then went the other way, and then it shattered back and forth.
Yeah,
If you had do you have code, or is it
I do not have code. This is all. I can look up the link for you right fast.
Can you look at the chip and see what on your motor controller, what chip are they using?
It's an Amtel chip.
Mm-hmm.
It's an Amtel chip. Basically, it's just it looks like to me to be a little Arduino. With I haven't looked to see what the actual the driver chip on it is.
Yeah.
I haven't really looked to see what that is.
Yeah, because I mean, there's only so much. If you have another chip, you could probably make that program work for almost anything, unless they've got some specific key that you have to have for it to not to work, which I would think they wouldn't put on a motor controller, but you never know.
Yeah, give me a second, and I can find this because I pick it up all the time.
I know that the gentleman who wrote the PID library for Arduino has a self-tuning program, and that's what I was wondering if this was that. But let's see how this one goes. Basic macro.
I wouldn't mind even if it was in Arduino, that I could probably convert it over to Python, because that's one of the things, of course, anybody has to deal with is, I wrote my own PID controller. It'd be nice to actually have something that could tune it for me, because I was trying to run it into GNU plot and all that kind of thing, and it was just, if I had an auto tune rather than and it also, I find that if I turn my robot on, it does a measurement of the battery voltage, and then obviously that impacts the PID controller. And so my tuning is based on the battery voltage at the time I did the tuning. And it would be nice if you could actually have that be another parameter and auto tune based on the battery voltage, because as the battery voltage goes down, you got to change that as well. So,
well, yeah, if your PID's working right, you shouldn't have to worry about battery voltage. It should just it'll adjust for it, because you're right, because you're not looking at voltage. What you're looking at is encoder checks.
Yeah, that's right. That's the whole point.
Yeah. So as long as your timing's right, your period's right, and your ticks are right, you within the capabilities of, obviously if you drop the voltage so low that everything starts to fall apart, but within reasonable range, it should just normally adjust for it. But you should look at, his name is Brett Brightson. Anyway, if you look up Arduino PID library, his name will come up. His first name is Brett, B-R-E-T-T, and he has an auto tuning library.
Oh yeah, I'll put the link up. Brett Beauregard.
Brett Beauregard, yeah, good Southern name.
Okay, I put the link for the RoboClaw, my motor controller, in there, and the link to where you can download the basic micro, and it looks like it may do a lot of things. This is the motion. The basic is called the Basic Micro Motion Studio, and it'll control a lot of their. I think they have a whole series of boards based off the same stuff. So I don't know how versatile this is going to be for you.
Yeah,
but that's the thing. I think Ray has one of these too. One of these RoboClaws running around too.
Oh yeah.
And I'm like, I said, man, this ain't gonna work. And I had to fuss and fight with it and all that kind of stuff, and found out that it was all the ID10T errors. Exist between ground and keyboard, and that'd be me, right? So once I got all the stuff wired the right way and the encoder signals going in the right direction in the right places, I hit that PID tune and it just worked. And then it seems to be very accurate, although I hadn't put it through its paces. So things like I know one of the things I can do is I can stall the whole thing out and brown out, make it brown out, because I haven't supplied what they call a logic battery. There's a 5-volt input on here where you, if you don't supply that, it'll just take the voltage off the battery that you supplied it to supply the wheel, and will give you a couple, 2 or 3 volts to run all the logic. But if I give it 5 volts directly, then when I start trying to stall the wheels out and stuff, it won't brown out the logic on it. So currently it browns out when I do that because I haven't completely plugged all that stuff in. Yeah, but those are the things. So I'll tell you, gentlemen, I am not feeling all that well at the moment. I think I'm going to go and get me another glass of water and probably lay down and maybe I might actually sleep. Who knows? I don't know about all this stuff.
Get well, Harold.
I would tell you, I don't think I'm really sick now. Thank you very much for it. I'll tell you, it's finally, my sleep patterns were bad enough before all this, having to hang out and, working at the house and stuff. And it's finally, I believe, gotten to me. So I got to do something drastic to get my sleep patterns back. Yeah. Anyway, gentlemen, it's fun hanging out with you.
Yeah.
Okay.
I'll see you guys next week.
See you, Harold. Take care of yourself.
Hey, can you guys see 2 ray images or a second ray image in there? Because I've looked at
Yes.
You can?
That's the other ray.
The other ray. What do you see? Is it
just a purple circle with an R in it?
Purple R. Okay. This is weird. Oh.
But one of them is muted, Ray. So if you look for the one that's muted, that's probably your Pi.
Okay. I can't seem to get to that one though. It's weird.
I don't know if you can see it. Let's see. No, it's just a big circle with an R.
Okay. If I choose to, can I try to present? Because that's from the Pi.
Yeah. The thing is, I'm not sure if it's. See if you're connected. If you go ahead and try and present. I was wondering if you got the video turned off somehow.
Well, I don't have a camera on the Pi. But I do have the Xbox images.
Oh well, yeah. Do the present. Maybe that's all it needs.
Let's see. An error occurred when you're screen sharing. Maybe that's not going to work.
Oh well.
I can try it again.
Yeah, good try.
I was just tooling around on Brett Beauregard's auto-tune Git page, and apparently there's a Google group called DIY PID Control. Is anybody a member of that here?
No. But the nice thing about his work is he's got a very nice tutorial out there about PIDs.
Yeah,
I've talked about it before.
Yeah, it's the one with the slideshow.
I don't know if it's a slideshow, but it's like several web pages, and he talks about each feature that he added to make it more like a professional PID controller as opposed to a hobbyist first shot. And it's a real good page, and so he obviously knows his stuff. So I would be interested in seeing if somebody actually uses tuning stuff. I wouldn't be surprised. Usually how they do that is they introduce a step to the. Otherwise, they get you going at a certain speed, and then they introduce a step, and then how you respond. thing responds to that step, they can use that to tell whether you're overdamped or underdamped and tune to it. That's why when Harold said it, well, it went one way and then it went another way and then it kind of chittered in between. I think that's what they're doing is they get it going one direction and then they turn it back the other way, and then they get it it should be steady state, and then they're introducing a sudden step into probably into the reference, and then it just boom, 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 how it responds to it. I mean, that's how I've read that they do it. You know, because a lot of these type of PID controllers get introduced into industrial processes that you can't have a machine and a big gear train, and I'll take the worst case, a paper mill, where they have a machine that's literally a mile long, and they have, you know, like probably 20 motors that are 100 horsepower or more, rolling rollers that are keeping this wet paper exactly in sync. You can't just suddenly introduce something into that or you just tear up everything. So they've learned to tune in a way that prevent destruction.
Yeah.
Anyway, so it'd be cool to see how, Pat Murray would be a great task for you. Take on that auto tuning and come back and tell us how it worked.
Yeah, well, I'm just looking on that Google page or that Google group, and apparently it hasn't been ported to Python yet. And there's been a couple people working on it, but nothing on the, you search the entire group and there's only 3 messages about Python. So it certainly looks like it's been done for Arduino a couple times, but not in Python. But I've got right in front of me the Python code for it, and it doesn't look easy, but it looks doable. So I'll probably download the Arduino code and have a hack at it, because it'd be nice to be able to auto tune.
Well, can't you in Python do C stuff?
Well, I could call this. Yeah, I could call this as a library, but part of this for me is learning. So if I can figure out how to make it work with my PID controller, since I'm the one that wrote that, it'd be nice to actually just integrate this into my PID controller.
Yeah.
So, but it's not a lot of code, but it's pretty complicated. But yeah, auto tune example. Yeah.
Actually, I don't know. I saw Will on. Hey, Will. Are you familiar at all with auto tuning PIDs?
Will is muted.
Yeah, but he said no.
Yeah.
He's very knowledgeable on them.
Yeah, it's like not a lot of code, but it looks like the kind of thing you wouldn't be able to figure out on your own easily. Obviously, the algorithm is everything, and if Brett Beauregard's already figured out the algorithm, then if I can basically port this to Python, I'd be fine.
Yeah.
Yeah.
Cool. So just a sideline question to Murray. You're running a Pi to control your robot.
Right.
That's why you Python. And it's keeping up fast enough to do all of the mechanical things. Sensors.
Yeah, absolutely. I'm not even stressing it out. I mean, I'm running Top, which is a Linux. You can run Top on your thing. I'll show you, actually.
Some people had told me that Pi has all kinds of, it's not good for the really fast stuff. That's why they use Arduino.
It's not really good for the real-time stuff.
Right.
So, yeah, you're right. And you're right, Doug. Traditionally, you would run your PID controls on the Arduino. Your motor controls would all be on your Arduino.
Yeah.
And what you would have out of your Pi would be something like, I'm taking the GPS readings and I'm turning them into a number which I send down through I2C to the Arduino, and it's just changing.
And one of the things that I did on mine, which I've talked about before, is that I'm not running just a Raspberry Pi 3. I'm also running an Arduino. It's an Arduino compatible, and it's what do they call these things? It's an itsy bitsy. It comes from Adafruit, and it's it is really tiny, and it's actually quite a lot faster. I can't remember. I think it's 120 megahertz, but it's just a tiny little Arduino compatible, and I'm actually running all my sensors through that, and
Wow.
then connecting that through I2C, and it was, in the end, it was a lot easier than I thought. I actually had made it more complicated than it needed to be because I was trying to generalize the whole thing. But yeah, basically I've got all of my infrared sensors on the front, which is 5, and then 3 bumper sensors on the front, all coming as pins onto that itsy bitsy. And then I'm just reading that from the Raspberry Pi, reading the Arduino from the Raspberry Pi. And that offloads all that processing. So in theory, you could do I could have multiple ones of those. I could have 3 or 4 of those on the robot and just run all the stuff through there and have the Raspberry Pi just take the high level stuff.
Yeah, that's the road I think I'm going to go down.
Yeah, it's not too hard. In fact, I'll go ahead and post my GitHub. I pay Doug. I was going to mention about GitHub is that sounds funny to say I'm a professional programmer. That's what I've been doing for 25, 30 years or more. And SVN is Subversion, and that's what I used to use. And in the last few years, I finally broke down and started using Git because all the places I worked use Git. And GitHub, of course, is just a commercial site that hosts repositories. And so I think it's $7 a month or whatever I'm paying. I get my own site on GitHub.
Free.
What's that?
Free.
Yeah.
Yeah, it's free now.
Free, but I want some of the features on the. Can you get a private for free? Doug?
No.
Well, you can on Bitbucket though.
Oh, okay. Well, I'm using GitHub because that's basically what everywhere I work uses as well.
Yeah.
So I pay $7 a month, and I get both private and public repositories. So I can basically post a project up privately and work on it. And if I want, at some point, I can make it public. And so I'll post the URL onto the site here about my homepage, and that's where you could actually go and get my Python code. But there's also the Arduino code that I'm using, and you could look at that and see how I'm communicating back and forth between the Raspberry Pi and the Arduino. It's not actually that hard, and there are some libraries that can do it for you if you want to do more complicated things than I'm doing.
Cool.
But I would recommend Git. Basically, every time I make changes, I do a check-in of my code, and I don't have to worry about losing anything.
Right. And you also can do it from multiple computers is another advantage.
I do it actually from the Raspberry Pi. I'm coding on my Raspberry Pi from an SSH shell. So I SSH into the Raspberry Pi, do all my coding on the Pi, and then just do git commit and then git push, and I push it up to GitHub.
Cool.
And it's actually really easy. It's like you just learn 3 or 4 commands and you're set. And then if I create a new Raspberry Pi, or a new robot, for example, I just do git pull, and I can pull the whole repository down onto my new robot, and I've got all that code. So it saves a lot of time, and you don't have to worry about losing anything. You've got revision control and everything. It's dead easy, actually. It's a single tool called Git, and once you learn that, and you've got either a free account on GitHub or a paid account, it's the same. Doesn't matter. It's really it's worth the trouble, believe me.
Yeah, and you can have private repositories on a free.
Oh, you can. Okay. All right.
Yeah. They limit. You can only have 500 megabits of GitHub package storage, but
we're going to use that.
you're probably not going to use that. And
be surprised.
there's 2,000 action minutes per month, whatever that is. But it's free for public repositories. 2,000 action minutes per month for the free.
Mm-hmm.
But if you pay for the team, the next level up, which is here in the US, $4 per month, you only get 3,000 action minutes per month. So whatever the difference is, I don't know. But you do
paying, because I think I'm paying 7, but that occurs to me might be 7 New Zealand dollars, which is probably about 4.
Yeah. So anyway, I'm just saying that if you got a small like me, I'd fit under the free without any problem, except that they used to not allow private. So I'm on Bitbucket. I do have a GitHub account, but my repositories reside on Bitbucket.
That was interesting, Ray.
Yeah, can you see that? You might want to pin my thing on your screen, and I can hold it up. That's the two images on the Pi.
Oh yeah.
Oh yeah.
Let's see if I can get it just
Yeah,
right.
that works.
Anyway, so that's the two camera, the depth camera and the other camera. Oop.
So it's actually running two instances, right?
Well, there's two streams.
That's really pretty cool. And
Yeah.
it's handling it pretty neat, pretty well on itself.
Yeah, I'm sure it's the Blair Witch thing going on here, but anyway. Yeah, I tried getting in directly and from the Pi, and it looked like it was working, but I couldn't present. So anyway, it's pretty cool. Yeah, on that, there's no delay. It's pretty fast for both images, and they're synchronized. It's not like move your hand in one and then it moves in the other or something. So.
Well, Ray, I'm thinking that you must have something going on with your system, because I'm using a Raspberry Pi 3, and like I said, when I'm running my robot with streaming video, I'm also writing to the file system an MP4 file, and so I'm both streaming to file and streaming to a web camera, and also running the Raspberry Pi itself and a big message bus. And if I run top, I think when the thing's running, I'm only running at 15 or 20%. So I'm not really hitting the limits on the Pi at all.
Yeah. I know OpenCV is a real hog, because you're taking, I could do that here. So just TOP, huh?
Yeah, top. And you can Google on how to configure it, because while it's running, you can just hit keys on your keyboard and it'll change the configuration.
Okay.
And you can even get little bars at the top that show you, like, for example, like both your memory and your CPU usage.
Top. Of course, I have to run that when I'm running all these things, right?
But top doesn't take much.
Oh, okay.
It's
okay. Or could I open up another command window and do it in that one?
I'll show you top running. I've got it running here.
Yeah.
Yes, you need another command window. That's what you want to do. Open a command window and then type in TOP.
Do it that way. Yeah. Okay. Yeah, I killed the other ones, so. But root PR percentage memory, percentage CPU. Okay, I'll try to get those up and running again.
And as you can see, I've got these little memory bars at the top, and that's just a configuration on top. You can, like I said, it's very configurable, and you can have different styles of displays, color, everything. It's kind of amazing how good it is, considering it's just a simple little command.
Yeah.
But I've actually got a little tiny, I think it's a 320 by 240 display on my robot. And once it's running, I just run top, so I can actually see the top running on the robot itself. So I can go over and look at the robot and see what it's actually doing without having to even SSH into it.
Okay. Let's see.
And that's how when the robot's actually running, I can actually be driving around in my garden and see how much CPU and memory usage. And like I said, it's never much. It's 20, 30% sometimes.
Yeah.
Yeah, but you're probably not doing any image processing, right? So, but if you have OpenCV and it's actually running algorithms and crunching on that video, that's
certainly more. I'm just basically running a Pi camera and streaming it. I'm not doing processing on the image itself any more than the camera does.
Yeah. The other thing, the advantage of using the native Pi camera is it's a lot more efficient. The Pi is more efficient at using that. If you're using USB-based cameras, and then especially if you're doing OpenCV image processing, it's got to first decompress the data coming out of those USB cameras.
Yeah.
You know, to run the algorithms. I mean, let alone all the traffic you get over USB.
Wow,
Which the Pi is fairly good at that, but I still think that camera serial interface, those CSI ports, are a lot more efficient at just moving all that camera data around.
Yeah.
And so with any USB-based webcams, I've read that, you know, you get bogged down a lot more quickly.
Yep. Yeah, I can imagine how much traffic the USB bus would have. Especially since, Pi 4 has a USB-C.
Yeah, and that's what I'm plugged into. I don't know. Well, yeah, probably
But the camera will be USB-A or B, won't it? If it's an old camera?
The plug goes in. I can plug it into either the USB 3 or 2 ports on the Raspberry Pi 4 because it's got 2 of each.
Yeah, but your throughput is going to be based on the slowest device, and if your camera is USB-A, like you've got an old camera, then your actual throughput on the camera is USB-A level.
Oh, okay, yeah. These connects have been around for a while. I think they came out well before, USB-C or 3 or whatever it is. Yeah, I've got to reset. These things, you get out of the programs in a rough way, like, with the Control-C, sometimes it doesn't restart without rebooting the Pi, and so. But I'll check that out later. I've got 2 windows, one with the top in it, and the other where I tried to get those 2 windows back, but they're not coming back. So anyway, okay, I'll try that though, and see what percentage it's using. There it goes. Okay. Well, CPU is 109.
Wow.
110. Memory 1.9. So not much memory. 123, 124. I'm not certain what the percent CPU means, but hopefully that's not supposed to be above 100%.
Oh no. Let's see.
Yeah, it's fast. Anyway. Yeah, it's like 122, 120 for just the CPU. 116. Looks like the video is not delayed, which is good. It's still, I'm guessing, since there's no trails or chop, it's probably around 30 frames per second. But yeah, OpenCV has always been a hog. I mean, some of the operations you're taking a smaller matrix like a 5x5 or they're always odd 7x7s, 11x11s, and you're multiplying that by all the pixels around it in the image, and then that is what determines what that center pixel becomes, and then you move it over 1 pixel and do it again, and so like the Gaussian blurs, they're extremely slow because the matrices that you're using to go over the image, or they can be an 11x11, and it just takes time. So, but
what does processor change to when you stop the vision processing?
It was like a few percent before I started it.
I'm wondering if
Yeah,
that's
it was
the addition of all 4 cores. I'm wondering if that's the addition of all 4 cores. Otherwise, the maximum might be 400 instead of 100.
Yeah, you'd think it'd max out to 100%, but it's over that. And that looks like Python is taking the majority of that. There's others. Xorg is like 50, and then they get pretty small after that.
Ray, I posted a URL that has a page about how to control top, and you can actually show all sorts of different parameters, and you can sort different ways and put bars at the top and what they call a forest view. So you can actually choose what the priority is of what you see. So so
yeah,
because if you've got 4 CPUs, you could actually, I think you're monitoring each CPU as a separate bar chart.
Oh, all right. Yeah.
Yeah.
Yeah. And I don't know if this was, well, I don't know, you know, Raspberry Pis, the 3s at least, have had 4 cores for some time. So doesn't necessarily mean that whoever wrote these programs for this thing utilized all 4 cores.
Well, that's what the benefit of top is you could actually see if it's maxing out on one and leaving the other 3 untouched, or whether they look like they're balancing.
Okay. All right.
Anybody else?
Yeah.
Well, I just thought I'd let people know when I spent some time on this. I'm starting to dig into Ron's code with the attempt to see if I can create my own robot configuration file on his simulator. Looking at the, Ron's pretty smart. It's reasonable. The code looks like it should be pretty doable. I think the more limitation will be me trying to figure out what I want to do. But however, the real problem with the simulator is that it assumes the perfect sensor, basically. And from what I've seen messing around with my robot, it's the sensors, the noise in the sensor, that's the real problem. Like I have in my particular little lab here, I actually have a center light in the room. It's very common. It's hung in underneath the fan. And I mean, it puts a glare on that course like crazy. And trying to get that glare filtered out, that's tough. But you figure that's robustness. You have to work on getting those sensors as perfect as you can. Where I think the simulator is going to be very helpful is in determining algorithm and sensor placement. Well, now you got to remember, unlike what Will's doing, Will's actually making a combination between a linear array and multiple IR sensors, probably IR diodes, but I'm not sure exactly what sensors he's using. I'm using a camera, so basically I have a field of 320 by 240 that I can place sensors anywhere in that field that I want to place, and so that makes it kind of nice for this simulator because I can just create my own sensor arrays using portions of the camera image and see what I can come up with. He also was for you guys who came Saturday, he's using an approach that I have kind of seen before, but I've never seen one take it quite as far as Will is apparently doing. Will is actually taking various elements of the course and then finding the optimum place to put a sensor that would trigger that particular tile. So I'm sure there's some room for that, but that's kind of, I think that when I watch his simulation, I still haven't figured out exactly how it's working. It's working, but I haven't dug through the logic enough to be able to see how he's following the line. It works, but I don't think he's using his linear array as much as you would think. I think he's depending on those external spot sensors more than I wish he was still on. I would like to ask him. Anyway, so I'm starting to dig into it. I'm hoping that I can create my own version of whatever they call it, basically your own robot, and see how it goes. But I'm real excited in the sense that it may be very useful to help tune algorithms. You know, if you say, if I lived in a perfect world and I did this, it would work, you know. And then spend the bulk of my time actually trying to figure out how to make the sensors look more like the perfect sensors. And
I actually stuck in a polarizing filter, and
yeah, I've already gone there, Ray. We're already down there. Yeah, I found this, by the way, and this is pretty cool. This is off of eBay, and you get 10. No, sorry, it's off of Amazon. You get 10 little film. Can you see that?
Yep. Oh yeah, yeah.
Okay, now watch this. They've got plastic film on it, protective film, but I think you can see if I turn it right.
Polarizing. Yeah.
So, but you know, glasses, sunglasses are only one, and that did seem to help quite a bit. You can see this one's got 2 holes in it. I don't know if you can see the 2 holes.
Yep.
That's the ones that are on my camera. On Thingiverse, I found a perfect M12 lens cap. It even has the hole for it. It's like a 1-minute print. You know, it's fantastic.
Yeah.
Did that in PLA. So anyway, if anybody's interested in this stuff, let me raise their hand and I'll put the link in. Nobody's interested. Okay.
Interested?
Yeah, sure.
I'm interested, Doug.
Okay. All right. I'll put the link in chat.
How many did you get?
You get 10 3-inch by 3-inch pieces for about $8.
Have you tried doing 3 filters? The weird thing that sort of helps illustrate quantum mechanics, where you put 3 filters in them.
No.
What?
So you know, if you put the 2 filters in crosswise 90 degrees, it blocks out all the light, right?
Right.
So so do that, and then slip another one in at 45 degrees in between those 2, and see what happens.
Whoa!
What happens to get us in suspense?
You've got 3 of them right there, don't you?
Yeah.
Another dimension.
All right. Here we go.
You're gonna bend light.
Oh yeah.
Make a time machine.
All right. Okay, so here's the 2. Let's see here. I guess that's 90.
Yeah.
Yep.
Yeah.
Okay. So now,
Wait, don't break the universe.
here goes 45.
And no, between. You have to put them between.
Between?
Yep.
Doesn't matter, should it?
Between the 2.
Okay.
Now rotate that to it's exactly 45.
You guys are. I don't know.
I think he's just playing
The
with
back of your head.
We can see through it. We can see some of you when you get it just at the right orientation. It starts letting some of the light through again.
Yeah.
Really? Wow.
Yeah.
Well, okay. Thank you for that. I'll do
to see it, but figure that one out.
Now the real question will be, is if I can screw with the auto. What do they call it? Auto light control. I don't know if you can change the brightness directly.
It occurs to me another thing you could possibly do is that every camera store I've ever been to in the last 10 years always has a bargain bin, just a cardboard box full of old filters, and they sell camera filters, polarizing filters, which are 2 of those mounted together, and they usually already have a little pin on them, which you could attach like a rod to and actually rotate the one beautiful glass filters, and they're usually like $1 or $2 in a bargain bin.
Yeah, the big problem that you have with that is the since this is an M12 lens, you know, you'd probably want to get a bigger lens to take true advantage of that, or you'd have this big honker filter on front. But it's a good idea. But actually, to be quite honest, most of the camera stores here in the States are dead.
Oh.
Yeah. The only place, I mean, you can still get a mail order, but you can't, you know, the ones where you just drive up and go look in there, they're gone.
Yeah, I guess you're right. The one I'm thinking of is actually a traditional camera store in Wellington that actually does sell film cameras still. So that's probably, the last of the breed.
Yeah, I think this might be some of the answer. And that might be to create a box of cardboard that.
Oh, a shield?
Yeah, and maybe even go as far as controlling the light from the inside of the box. Otherwise, the camera sees a field of about 6 by 6 or 6 by 4. Okay, 6 by 4 inches. So it wouldn't be too hard to create a shield that completely made it independent.
Well, that's what Will did, isn't it?
Well, that's what he did with his linear array.
Right.
I don't know about his spot sensors. I haven't seen, you know, actually I probably need to review the video when they presented, because, you know, he did hold the robot up and do, I could probably see where he put his spot sensors. Since I'm familiar with the robot, I can know where to look. Yeah. But anyway, we'll see. I'll dig up that link now and put it in the chat.
Okay.
If you play with it some more, I would be interested to hear if how it worked if you just turned off the linear array entirely in software, because it looked like it was way too close to the center of turning of the robot.
Well, you got it. I thought
I bet it would still work on basic spot sensors.
I was with you, but then you have to realize what he's got. He's really got an ice cream truck. I mean, an ice cream pedal pusher. You know, otherwise, his controlling wheel is not in the front; it's in the back. So the distance from his thing that's turning.
Doesn't matter where the controlling wheel is. What matters is where the center of turn is.
Yeah, but that's going to be, like I say, it's 3 inches in front of his turning element. So you know, because he always talked this talk about, well, it should be directly between the wheel, and I was trying to say, well, with a differential robot, that didn't make any sense, and Ron proved that. You know, we moved it down to the center, and the damn thing went unstable.
Yeah,
I mean, you know, and if you look at the speed line followers, they always put it way, way, way in front. Now, they obviously not making 6-inch turns, but you know, where they're going for speed and they have very gentle turns, they put that sensor so far in front, it's almost ridiculous. So I hear you, but I think that he's getting away with it, because I think between the wheels is actually 3 inches away from where he's actually turning.
Yeah, the thing is he's turning the tricycle part. The wheels are just rolling. So the place where he's got his sensors,
I see.
Is very much as if it's in front of where you would normally think of it being a normal differential robot.
So the center of rotation is not between the two drive wheels.
Right.
Well, they are drive wheels.
But that's not where the center of rotation is.
Right.
Right. Well, Yeah, the center rotation is somewhere else because the drive wheel is actually his tricycle, which is the thing that gets steered.
Oh, he has a single drive wheel?
Single drive wheel.
Oh, so the other two are.
In other words, it is exactly like a tricycle.
All right.
So if you think of a real tricycle, he's going backwards.
Got it.
He's pedaling backwards.
I think I'd have to take a look at the ice cream guy and see what his does. You know, how he, you know. Maybe you buy an ice cream and tell him to go in circles.
But no, but I mean, Ron, you know, put that to rest. I mean, what everybody thought that what in the world was he think? You know, why would you do it in the middle? You know, Ron actually showed that didn't work. So I felt.
Yeah,
I felt a little bit vindicated there because I could never figure out what was going on with, because, you know, Will's very sharp, so he's not going to be telling you something that.
Will does not have his sensors at the center of where his rotation is.
Right, exactly.
Yeah.
Okay.
Well, actually, he does.
No.
At the center of it, no, at the center of where he's rotating.
No, it isn't.
The controlling element is three inches away.
Because he's not rotating around the center where those two wheels are.
Yeah, but if he took his wheel and turned it 90 degrees, he would spin around. And where would the center of the circle be?
The center should be between the two riding wheels.
Yeah, the two.
Those aren't driving wheels.
They're not driving wheels. You're right. But if you took the driving wheel and turned it 90 degrees and ran a circle, the sensor would literally be in the center.
No, it wouldn't. No, it wouldn't.
Yeah, it would.
It would.
Because they can't sideways.
Yeah, I have to think about that. Where the exact
The rear wheel would just be on the perimeter, basically driving around the center.
But it's not the same as a differential robot, because in the differential robot, why isn't it different? It's just different. It's just different, guys.
It can't actually be different unless the wheels were slipping a little bit.
Yeah.
Okay, if
the wheels would actually.
The wheel is at 90 degrees. I think it is going to rotate between the two wheels in the front. Is that correct?
No, that's wrong. That's
where
wrong.
do you think it's going to rotate?
Okay. Here. See the picture where here are these wheels and there's the wheel that's driving?
Yeah.
It's not going to rotate around that point. It's going to rotate around some point over here.
Okay.
I think it will rotate behind the two wheels, but closer to them than the drive wheel.
Well, that may be, but what I'm saying is that the wheels are actually going to have to slip.
Yeah.
In other words, unless this,
they don't have to flip.
Unless they're all on a circle. Unless they're all on a circle.
I guarantee they're on a circle. I'm sure he did that.
Okay, they're not on a circle. Okay,
Yeah, they're not on a circle.
and if they're not on a circle, then then it's not going to rotate around where between those two wheels.
Yeah, but if they are on a circle,
they are on a circle. They're on concentric circles.
The demo driving it.
I don't
They're
think
on concentric circles.
it's off center.
Yeah, I don't know.
well, I'll tell you what I can do, David. David, I won't do it here because I'm sure, but I can run the simulator with his model, and I can make him go in a circle, and I'll record it. And I guess I can record it, and I'll show it next week.
Okay.
Okay.
Yeah.
Yeah, because I mean I'm with you in the sense that the idea of putting a sensor between the two wheels of a differential robot and trying to follow a line is just not going to happen.
Right. That's nonsense.
And I mean, like I say, Ron showed that. He moved it in his robot, he moved the sensor back. I mean, so I'm not sure exactly why. Like I said, I just know it's different. Because it does follow the line very nicely. Like I say, I still haven't figured out the sensor logic, but the
My question is, what if you just turned off the linear array? Maybe that would indicate that it's all happening from the spot sensors.
That's a good point too, and I might try that, because I would be interested to know. You know, just like I said, looking at it, it's not clear to me where he's getting his signal from. But I'm gonna, you know, that I'm glad you guys are here, because I've got two new experiments to try on the simulator. Hey Carl, welcome back. Are you gonna put that code up in GitHub? Did Ron agree to that?
You know, he agreed to it, and he sent a draft or two, and then he said, "Wait a minute, I have to fix something," and I haven't heard back from him since.
Okay, because I contacted him separately because I just wanted to play with it, and I don't know. For what it's worth, I'll let you know. I've got the. Oh, dang it. Where did it go? I have the August 11th version.
Let's see. I'm going to check here.
11th. So if he's got something newer than that, yeah.
Or if you have something newer than he sent me. August 12th. August. Yeah, I don't know if you want to send me the August 11 version.
Okay.
All I have is a movie of him at Lake Louisville, apparently.
Yeah, he was up at Louisville for the Lucky Dog, sitting up at a lake house. You know, must be
there
tough.
it is, August 11.
Oh, you got it? Okay.
Yeah, I got the zip file, so I'll put it up as it is.
Okay. Yeah, that's like I say, you know how it is trying to read somebody else's code. It's always a little weird, but there's like I say, I'm trying to work through Will's example so that I could write my own robot, because the differential robot model that Ron wrote is very basic. You know, he never meant it to be able to do the challenge course. He meant it to do the advanced course.
Right.
Yeah. So anyway, that's all I got. Like I said, I'm starting to play with that, and I think its real value is going to be in helping to do algorithms. And I think the real problem is going to be determining how to make the real sensors look similar to the ideal sensors. And that's going to be I'm going to play with some stuff. And you guys gave me some ideas, and I'm going to go see. I would have never thought about the 45-degree between the two 90s. That just has no, you know, I didn't even know about it. So that's really cool. And but like I said, I got some improvement just with glass. You know, I started this out by just taking a pair of old Polaroid sunglasses and sticking one underneath and seeing how it worked. And I've got like almost exact worst case, a bright light centered right over the robot. I mean, it just blows out the black on the course into a big white smear. So getting that tuned out is going to be really interesting. Anyway, that's all I have, guys.
Yep.
I got a quick fail to share.
Yes.
Okay. Hey, are you, before you start, let me ask you, are you getting in on Greg's $25,000 free giveaway thingy?
They started that last year, and they gave us the stiff arm. Well, we were one of the first to apply, and I'm pretty sure it was a pretty good application. But they also know the team, and we've been over to their headquarters multiple times, and I think that they sort of felt that there are other teams that are more in need, perhaps. At least that's the story I'm going with.
Good.
So I guess I'll try again this year, but they've got a lot of teams applying for it. There's 5,000 teams out there.
Well, you learned, right? You guys got to look like a lot of hot yahoos, right?
That's right. We're some yahoos. There's no doubt.
They gave you the stiff arm, huh? Oh, wait.
Yeah. Like, I don't think that it was just there were tons of applications in there.
Yeah.
Let me present the screen real quick.
Did you bribe them?
Should have tried that.
Yeah, could have worked.
Oh, wow.
Let me guess.
Don't tell me you went in the water.
So that's just the robot hanging out at the beach. You can see it was pretty sparsely populated. This is the robot moving around a little bit.
That's cool. I didn't know you tied a rake to it.
Yes, the brake on the back is the pivot wheel.
Oh, it's a pivot wheel and a cookie trail dropper.
What was it trying to spell out on the beach there?
So that's the robot. You can see a couple of fails there. One is that this is the GPS antenna. It fell askew. It kept falling off. And then, so this is the location. Let me present a different screen. So this is the location.
Oh yeah, I see it.
So that's the KML file that the robot was supposed to follow on the beach. And I say supposed to, that's where the fail came in. The team was, they were working on it remotely. Yes, we were coordinating our updates through GitHub. They created this path for the robot to follow. They created the path following code, but it wasn't quite right, wasn't quite there. And while I was, I'm going to show this is the actual location where I was staying. We had the GPS and the base station set up in this corner of the building right here. And our condo was the one on the ground floor facing the ocean right here. And I had the robot tooling around on this grass area, trying to do the PID, trying to tune the PID, and it broke the rake. Pulled the rake right off, and while we were doing some stuff at the beach, I didn't have permission to bring my whole toolbox with me, so I wasn't able to fix it. And that was, by that time we were at the last day, and so we just didn't quite get around to finishing the path following. Would have been nice to have a video of it,
That would have been cool.
So did it spell another 4-letter word, or?
No, it broke. It broke while I was doing basically Foursquare. What's it called? Four corners or whatever.
Yeah. Yeah.
Using basically tracing out a big 10-meter square as a calibration test. And while I was tuning the PID, while it was doing that, it got hooked on some grass while it was going backwards. And when you got a rake configured like that, you can't go backwards. So
Yeah.
it pulled itself apart, and the robot needs some repairs. But we got a good start on it. And another problem was that for some reason, with the base station I had set up right here, I was only able to get float RTK accuracy, which isn't the same as a full RTK fix. So the accuracy was probably at around half a meter. It might have been okay. It would have been a pretty wobbly looking little logo there, but it might have been able to work. But for some reason, when I'm using that base station I found in Richardson here in Dallas, I'm getting a better fix. So we may try, I'm going to look for like a dirt baseball diamond, maybe where I can try this out here locally.
Yeah, it'd be cool if you could do like some, you know, like what they do to line football fields with and stuff. That might be an alternative.
Yep.
You know, instead of a rake, you know, just something that, or maybe even on a big sidewalk, some chalk. If you could, you know, maybe buy a package of sidewalk chalk and put them next to each other so they're like a rake, but you know they're not a rake.
Yeah.
I'm just some ideas.
Yep.
You could say DPRG was so big it could be seen from space.
So this is yet another autonomous mower project, basically. That's what the robot was originally designed to do, and that's why it has a rake on it, because you know that can sort of do that path combing effect as well. So we got a ways to go to see how much traction we get with this, but it was a good start for a summer project, and hopefully there's more coming, and we'll be able to demo more fully what the different things that we're doing.
That's pretty cool.
That's it.
Yeah, North Padre, you could probably just rake the plastic out of the way and it would show up, you know.
It's actually, you'll notice why I think I stopped presenting, but the beach is raked on a regular basis with large machines to get rid of the trash.
Yeah.
So, but yeah, it would be a cool thing to have a little team of those doing tooling around down there. There was another video that I didn't show when the rake. So another fail was that when we're going over very dry, loose sand, very fine sand, it digs in. The rake sort of pulls down underneath the sand, and it gets a big pile of sand building up over the tines, and it basically stalls out. And then so the wheels are spinning, but it's not moving anywhere. So it is very sensitive. So the sand that I was going around on was sand that was basically close to sea level, and it was fairly wet.
You know, I had a similar problem with my van, basically.
Yeah.
You don't want to drive it into the unpacked sand unless you got 4-wheel drive.
Yeah, a lot of cars get stuck on the beach that way.
Then the locals with the 4-wheel drive pickup can make a nice sum of money by just laughing as they tow you out.
That's right. Yeah.
Yeah.
Happened to me in New Zealand.
Yep.
Tried to drive on the beach, and they said, "Oh yeah, it's fine." Got about a few feet out there, and it just.
There you go.
Did that video stream okay for you guys?
Yeah.
Okay.
It streamed pretty well.
Yeah.
That's all I had.
Who's left?
I'll go next if we have a few minutes left. So we were talking earlier about I was promoting the idea of a wireless way of tuning the parameters and how much of a time saver that can be. So I just wanted to just show what that looks like on my end real quick. Let's see, how do I present?
Kareem, I think you're presenting.
You're looking for the present button now.
I stopped presenting.
Not according to me.
Yeah, it's still there.
Yeah.
Okay.
There you go.
Now I get the present now button. Okay, so hang on, your entire screen. Which one? Okay, that one. So let's see if that works.
I see code.
Okay, yeah. So what I wanted to illustrate, because most of us, have some code, and this is I think this is my wall following state machine code. But you have this code, and you realize, or I realized, I got parameters in there that I think I need to tweak, and target distance, right? I think that it's like, how close to the wall do I want to be as I'm following along the wall, right? Do I want to hug it more closely, further away, or how fast do I want to be going, and how quickly do I want to slow down if I'm getting too close to the wall? These are all, there's like probably more than a dozen parameters, just in this piece of wall following logic that at least I found, hey, it'd really be beneficial to tweak them. And so what I ended up coming up with is a way where on the other end of this code is a user interface. It's not particularly sophisticated, but I get a bunch of parameters. In fact, what's in here gets automatically populated from the code. And so you can see this is group 10 wall following, and you see this target distance here, and it's assigned 16-bit integer, whatnot. And and I'm not running, I'm not connected to anything here. So, but the idea is I can use this user interface to sort of, tweak the numbers as the robot's running. But again, because to just kind of make this more streamlined in terms of the workflow, what I ended up doing is, in terms of the code, like I said, the UI pulls these definitions from the code. So I did a sort of a little bit of C macro magic in two places. One is in one place where I'm just defining, kind of creating the parameters. So that's in one file. And that file is both used on the robot code and in the user interface. And so that's where the text comes in, right? What target distance or whatever, right? That's what's on the display. And I give it a data type and whatnot and the default value. So in one place in the code, anytime I realize, hey, I need a new parameter, okay, I go add one here to a particular group here. I would be adding, let's say, number 20 to this group. And then in the code, back in the code where I'm actually using variables, right? What I have at the beginning of this function here, which is just a state machine, I have 2 or 3 different macros that come into the picture that tie this code, into this super simple database kind of mechanism where I say, okay, yeah, in this function, I need access to parameter 1 from group 10, and I'm going to assign that, I'm going to call that the variable interval, okay? Well, here's what target distance we were looking at, right? I do have to say, again, it's assigned 16-bit integer. It's not smart enough to know that on its own. I just have to say there is this parameter, and it's group 10, parameter 3. And then a couple macros later, all of that plumbing is set up, and these parameters get automatically updated. So as the code runs, and this is a state machine, so it gets run at some rate. I think I was doing this robot at 50 hertz. And every time through this, first thing I do, I update all these parameters, right? And then I get into my actual code, right? And then this variable target distance would have the latest value of my target distance parameter that, again, would come from this user interface. And again, as my robot's zooming around, following a wall, I would be tuning this, I would be changing this, and trying out different values for distance. And you can see some PID, coefficients there, and all the usual parameters that everybody has and usually has hard coded in the code. So again, I found this a real time saver, and I took a lot of time to put this in place. But in the end, I found this to be a real time saver, and I would never do any robot any other way. If I don't have a way of remotely tweaking parameters, I'm just not going to do it. It's just I can't do it any other way anymore. It's just
well, Chris, this is Murray. I have one question. I'm kind of doing something, well, not similar, but I'm using a YAML configuration file that I read, and I've also got a Flask server running, so I can pop up configuration information on a web page. But the question that comes to mind is that, as most people, I basically read that configuration file when the program starts up, and then I never ever go back and get those values again. So how much infrastructure coding is there just to have it so that, let's say, for example, of the maybe 100 variables that I'm reading when I start up, how many of those I'd have to choose that I want to have dynamically updatable? But there's got to be some code that basically, there's infrastructure code in order to have it read that every 20th of a second or whatever that cycle is on your state machine. That must have taken a fair bit of time to write that, though, isn't there?
Yes. So there was a bit of a time investment here, and again, this isn't the most sophisticated solution, but it isn't super simple either. So it did take writing some infrastructure code to get all that plumbing into place. But I really felt I needed that. I found myself just spending way too much time doing simple tweaking of things that again, the workflow was too time consuming for programming and debugging a robot. So I felt like I really had to invest some time in improving the workflow. And mind you, this is before I did Raspberry Pi stuff. So this runs on an Atmel, an Arduino type of micro, right? So there are no configuration files that this platform has access to. This is all running on an 8-bit micro, and so it's talking back to the PC over Bluetooth, like I was saying. And there is a bunch of stuff happening in the background constantly. There's an amazing amount of work you can get done on an 8-bit micro running at whatever 20 megahertz. But in terms of time taken to write the plumbing behind this, yes, it wasn't trivial. Again, it depends on what your skill sets are. My background is software, right? So that stuff comes more naturally to me than working on the mechanics of the robot. So it wasn't that hard for me to do.
I think I'd be doing mine in Python with a YAML configuration file, but thank you for the idea. I like this quite a lot, because I wouldn't try to do it for all of my variables, but for, let's say, for example, the PID controller and stuff that is dynamic, I wouldn't mind basically reading that YAML file into memory and then writing it as a preference. What I've done before in Java is read a YAML file into memory and then write it as a preference file. And then when you start up, you see if the preference file is there, and you use that rather than the original. So you've always got this original. And then what I would do is go ahead and build out a web page like you've done with all those parameters and be able to dynamically update them. That's a great idea.
Yeah, I mean, once you're on the Raspberry Pi type platform, there's a lot more sophisticated things you can do anyway. You've got the extra performance, you've got the Wi-Fi connection, whatnot, right? So life gets a little easier in that regard on something like a Pi platform doing stuff in Python. But this was before I did that, and so this is plain old C code on an Atmel.
Yeah, this is really neat. One of the questions that I do have, though, just because it seems like it would be more efficient, it would be to have a flag that said that one of the your interface, your PC interface, would recognize that one of the parameters had been changed and would send a something's changed flag to your thing, over the Bluetooth, so that instead of polling this file all the time in your code, that you would only, once it did initialize, that it would only do it if it was changed.
Yeah, and it's sort of doing that. So even though it's running these macros every time through the loop, and this is 5-year-old code, so I don't remember the details. It is at the end of the day looking at some flags behind the scenes. And in fact, my program here on the PC, it's not sending all the parameter values all the time to the robot. I don't have enough. Well, I might have enough bandwidth over the 115K link, but that's not what it's doing. So it's every time I forgot what I'm doing in the background in the direction from PC to robot. I think there's something I'm doing there. Well, I think that's mostly events, if I remember correctly. So every time I hit the plus or minus button here, on my protocol, there is kind of a message that gets generated. Value gets updated on the robot, some flag gets set, and then a little bit of work takes place. But
Okay.
but granted, yes, just running these macros here, they do have to look at a flag somewhere. Yes, that does take a little bit of time, but really, it wasn't. The overhead on the robot was insignificant, and on the Bluetooth link, I didn't send this data all the time.
Yeah, it's a great idea.
Yeah, I did, however, on the
really
Bluetooth link in the other direction from robot to PC, since you brought up efficiency. I mean, in that direction, actually, I was constantly streaming all the values, meaning sensor values, all the time at a fixed rate. I actually find that to be, even though it may seem inefficient, even if nothing's changing, I find that to be quite useful. So I can actually have a complete recording of what the robot was seeing right after I run it around.
Yeah, but like KP, you wouldn't do that. I mean,
KP is a parameter, right? Exactly. That I wouldn't do none of these parameters. But when it comes to the actual sensor readings, I have some ultrasonics on here and some sharp distance sensors. Adds up to a dozen or so sensors, right? I would be sending those sensor values all the time from the robot to the PC. I found that to be useful.
That makes sense. That's great. Very cool.
So yeah, so that's again, it's like I said, I find that a huge time saver. Obviously, once you overcome the initial sort of investment of infrastructure coding here, that's that. But that, like you brought up, somebody brought up, right? The cell phone. You got stuff nowadays on the cell phone that make it a little bit easier. But I needed it to be a little bit more configurable, and so I did find myself. In the end, in hindsight, I did find myself probably reinventing some of the tools that you get with RAWs, right? Where some of the stuff, tuning things, making it, visualizing what the robot's doing and seeing, that's the kind of stuff RAWs does really well, right? And I didn't have that on my, Arduino-based robot, so I kind of had to, create some of this tooling myself, right, with the Visual Studio sort of UI there.
Yeah, it's really neat though. Very cool.
Yeah, definitely a time saver. Bluetooth is your friend, because it's so simple, right? It's easy to deal with a serial port. It's just so easy.
I can't recommend online real-time instrumentation and telemetry enough. I mean, it's absolutely terribly useful, and we even use it for doing our PID tuning. So I don't know if this would be directly beneficial to any of you, but we use a tool that was sort of built by another team for our infrastructure. So it's called FTC Dashboard. And just to give you a quick look at what it looks like. So there's a web server that's built into our controllers, and this sort of leverages that infrastructure. And you can set it up so that you can show, what the what the field looks like, what your robot looks like while it's moving across the field. You can graph different variables that you're interested in. You can populate those variables simply by decorating them with in your Java code. So you just put a little drawing a blank on exactly what it is. It should probably say here. There's a separate telemetry thing, but for common variables, yeah, you just put this config annotation on it, and then all of a sudden, everything that's in that any of the public variables in that class will show up in the dashboard. If the ones that have an edit box in them, you can change them on the fly while it's running, even like in the middle of pit control, and you'll see what the change in behavior looks like. So for us, it wasn't a huge amount of setup to learn to use this tool, but once we did start using it, it was just incredibly beneficial.
Wow.
Neat.
So it's worth the investment. However you get there, I can definitely advocate that it's worth the investment in getting this set up ahead of time. It will end up saving you a lot of time.
Hey, Chris, is there any way you would be willing to share your code or anything?
Yeah, I mean, definitely. I mean, it's on GitHub. I'll post the link
Can you
here.
put the link in the chat?
I will do that. So yeah, so that is there. Is it well documented? No, but
but it's the idea, and it's nice to see somebody who's done it, got it good, working good.
And we have a low bar for well documented here, so like, do you have variable names with more than 1 or 2 characters? That's probably counting for well documented.
Self-documenting code.
Some people have the knack. They can name variables in a way that you just know what they mean.
Yeah.
I'm not one of those people. I always have these long ass variable names, which kind of mean something to me, but when I look at them, I say, God, that's a long ass variable name, and I just wish who has that knack? David Anderson. When you're looking at his things, you might say, well, he'll have something like move, but his move will be, in the right place and will define the right thing so that it really makes sense to call it move. I would be like, move left on something, or, but, he's really good at that really abbreviated variable names, but also very useful. Anyway, hey guys, it's getting late. I think I'm going to have to haul out of here. So it's been a very good meeting. I really appreciate all the things that people have shared. A lot of good stuff, and I'm seeing that board behind Doug, and I'm curious to where he's going with that. That's going to be cool. Anyway, I'll see you guys.
Getting into territory.
Bye-bye.
Sounds great. Good night.
Yeah.
Take care.
Bye.
Hi, guys.